All right, everybody, we are going to talk a little bit about the results from your exponential growth in the coronavirus Nearpod. You had 5 questions to answer, and then there was a poll question. I don't want to give you something as usual and then not discuss it. Just one thing, I hope you all are listening. You will be doing Nearpod again for this week's kind of new content. Please make sure when you go into Nearpod, put your first and your last name where it says name before you begin, because all of my classes are funneling into one report on Nearpod, and I just need to make sure that you do your first and your last name. So, if you can remember at the end of this exponential growth in the coronavirus Nearpod, I asked a poll question like, yeah, I get this, or option was, I need more review, or option three was, I have no clue. And a lot of you, felt comfortable and you're like, yeah, I got this. But I feel like the majority of you answered, I need more review. So we will be doing I think it's task number 3 this week. You'll be doing just some examples with me, um, just a recap, because the last time you saw this material was our last unit test before all the chaos of this began. So it's fair that some of you are forgetting. Um, so I'm going to go over this with you now, and then you'll have a chance to review as it seems like most of you need. Okay? So, number one is basically asking why is this growth of the coronavirus not going to be linear? Like, why is a linear relationship not a good model? And a lot of you answer this um, pretty precise, meaning that we know that linear relationships are growing at a constant rate of change. And with the coronavirus, we know that in the United States, that the number of cases per day is not the same. And we know that this it will speed up. They tell us that it's going to get worse before it gets better. So the cases will drastically change from day to day and grow, and then it will slow down, hopefully, eventually. And what the graph or the video said, it will hopefully eventually kind of taper or level off. So because it's going to increase and then slow down, that's definitely a good reason why it's not linear. Number two, when the narrator did talk about how the graph will eventually level off, meaning the cases will kind of steady off. We call that line in our class an asymptote. A lot of you got that right. Very good job. Number three, this was the question that had the most um, amount of differences, I can say, in your answers. So as I kind of pull this up, I want you to focus on the black part, this black box. And I snipped this from the actual video. So the question you answered did not pertain to this data, but I wanted to show you what they were doing to find the growth factor. And I think some of you are confused. The growth factor is a little bit different than the growth rate, although they're very um, similar. So if you look, what they did is they basically said from March 3rd to March 4th, there was an increase of 2,159 cases. And then from the 4th to the 5th, an increase of 2,964 cases. So obviously it's getting bigger. So they took this number from obviously the later in March, and they divided that by the other difference. And this 1.37 gave you the growth factor. Now, if you dissect 1.37, we were used to adding in our exponential growth equation 1 plus this 0.37. And we know you added 1 to get you over, obviously, the number 1, because if something is increasing by 1, that means there was no growth. If the growth factor is larger than 1, we said that's exponential growth, and if the growth factor is smaller, then that's exponential decay. So both of these examples are showing growth. Now, in the video, let me delete this box, I don't need it anymore. It defined, and I pulled this up, it defined the growth factor um, as a ratio, and I literally took this word for word from the narrator. It's the growth factor is a ratio between two successive changes. So in question number 3, what I wanted you to do is I wanted you to figure out between the 16th and 17th what was going to happen. Now, you only could really find one thing going on here because we did not have the data for the 19th. So I've kind of already pre-looked at this data, so I was prepared. So if I pull this note, it's big, but what I did is I went ahead and found that from March 16th to the 17th, the number of cases in the US from this chart anyways, there were a growth of 1,778 cases. And then from March 17th to the 18th, it grew by 2,846 cases. So what that means then is we're going to take those numbers, and if I can move this and kind of show you here, if I can take the numbers that we just found, then I would take 2,846 and I would divide that. So if you did this, and you can recall doing this, awesome job. So when I divide that out on my calculator, that gives me about a growth factor of 1.6. So the growth factor that we should find here should have been about 1.6. And so that kind of shows you the math. Hopefully that helps a little bit show you the math of how I got that 1.6. So I can get rid of my math here. So what you then had to do, and if you can see, I can't really go any further because I do not have this data right here. So where I'm blacking out, if we had that data, then we could find kind of another growth factor from another kind of set of days. So then what you had to do is you then had to answer question 4. Now, obviously, if you had your growth rate wrong, then, but most of you, even if you got the your growth factor wrong, then you were okay. So what I'm going to do is pull in my work for number 4. So if you can see in my yellow box, the first thing I have right here is our growth, exponential growth formula. So what this means, if I can draw on this now and help you out here, 1.6, if you can remember, is our growth rate. 159 is the initial amount. I'm sorry. So 0.6 meant that from our March 16th, 17th, 18th data, that the growth rate was 60%. So that's 0.6 as a decimal. Now the growth factor is all of this together. So the R in this problem would be 0.6, or a growth rate of 60%. The growth factor, when you add that to 1, gives you Y is an exponential growth. So when I took 1.6 to the 27th power and I multiplied that by our initial amount in our table, 159, we, on April 1st in the United States, this would be predicting that we would have 51,598,450. Now, I'm on an app right now on my phone just to kind of give you an idea. And as of today, what is it, March 29th, there are currently 141,623 cases officially confirmed in the United States. So now keep in mind, this was predicting out to April 1st. So I'll have to come back or someone email me or send me something to see where this prediction and see how close it was. But that's really how you do that. So there's going to be some notes in task 3 that's going to help you kind of understand the difference between growth factor and growth rate. So I can trash that now. And then the very last question I just thought was good because even though you might not think that you use a lot of Algebra 2 in your daily life, we are looking at graphs quite a lot lately, especially with this virus. So basically, I wanted to kind of look at why would this graph be misleading? And a lot of you gave really good answers. A couple things that I think it's hard to understand in this graph that's not made clear if you were just given the graph is that it makes it look like the U.S. has way fewer cases, which as at the moment, current to date, we have more than China and Italy. But this is actually just talking about the deaths. So I don't like that this graph, it doesn't have a really good title. I think it's misleading, but I think it's also misleading because it makes it look like US has fewer cases, when in reality, this blue line is just basically letting us know what was in the question is that the US is trailing Italy by a good 1 to 2 weeks. And so that was really the main thing I wanted you to get out of this is that sometimes graphs, depending on who make them, and unless you have a really good title or something attached to it, you need to be really careful. So I hope this helped a little bit. Good job for this first 3 days, most of you, of our online learning. We're going to slowly this week, after you do some review on exponential growth and decay, we're going to move back into chapter 7 for our rational expression work. All right, thanks, y'all. Bye.